Hey kids, Flexing Teacher Weber here. Hope you're having a good day. We've been studying dividing fractions. Now the last time we worked on dividing fractions, we worked on dividing a whole number by a fraction and what that looks like and what it means. And we're going to continue that today, but we're going to look at all fractions, including proper fractions and mixed numbers. And we're going to start hopefully finding some connections and making some connections and finding some patterns and eventually move from the pictures to the numbers. So we'll start off with a very basic example, the fraction 5 over 10 divided by 1 over 10. And that means how many 1/10ths are in 5/10ths. So when you say it like that, a lot of kids just solve it by mental math. How many 1/10ths are in 5/10ths? But let's take a look at what it looks like as a picture. So if you think of the rectangle as one whole, then in that one whole, let's start off with 5/10ths. So let's divide this one whole into 5/10ths. We can cut it in half. And then take each half and make it into 5 equal parts. 1, 2, 3, 4 lines to make 5 equal parts. 1, 2, 3, 4 lines to make 5 equal parts. And shade in. 5 out of 10. So there's 5 out of 10. Now what the question is asking us is how many 1/10ths are in 5/10ths? Well, this amount right here represents 1/10. Let's count how many of those are in 5/10ths. I count 1, 2, 3, 4, 5. So the answer is 5. 5/10ths divided by 1/10 is equal to 5. Now, I want the kids looking for patterns, seeing if they can find any patterns in the numbers. So to do that, we have to do another question. 6 over 8. I'll write this a little smaller. 6 over 8 divided by 2 over 8. How many 2/8ths are in 6/8ths? Well, let's divide our rectangle into 8ths. Remember, our rectangle represents one whole. And we want to show what 6/8ths look like inside of that whole. So we'll divide it into 8 parts. Shade in 6. So there's 6/8ths. And we want to know how many 2/8ths are in 6/8ths. So this amount right here represents 2/8ths. We will count one group of 2, 2, 3. So how many 2/8ths are in 6/8ths? I count 3 of them. So the answer is 3. 6/8ths divided by 2/8ths equals 3. Okay, so those questions all had same denominator. What happens if you have a different denominator? Like 7 over 9 divided by 1/3. Well, in order to show that, you have to get a lowest common denominator. So if you can get a common denominator of both these fractions, you can put them all on the same fraction strip of one whole. So most of the kids pick up on really quickly by grade 8 that the common denominator of 9 and 3 is 3. Is 9. So you'll want to write both fractions with denominator 9. 7 over 9 stays the same, but 3 times 3 gives 9. And we do the same thing to the top. 1 times 3 is 3. So that's 7 over 9 divided by 3 over 9. We can now put this fraction as a picture. Both of them we can represent as a picture on this strip. So we want to divide this strip into 9 equal parts. So a good way to do that is to do thirds. And then divide each third into 3. And you'll get 9. Okay, shade in 7 over 9. Okay, and now you want to figure out how many 3/9 are in 7/9. So that amount represents 3/9. Well, I will count 1. I will count 2. You can't make another group of 3 9s. So the answer, you get 2 whole groups. You have 1 left over, because remember, we're only worried about the shaded part. We're only worried about how many 1/3 are in 7 over 9. So you have 2 wholes, 1 left over, out of what should have been a group of 3. So that's 2 1/3. Now at this point, hopefully the kids have started to pick up on some patterns. Look at this. To get the answer in this one, you could have done 6 divided by 2, gives you 3. Right here, 5 divided by 1 gives 5. Does it work here? Well, we call this the common denominator method. So let's see if it works for 7 over 9 divided by 3 over 9. So if I take these 2 fractions, 7 over 9 divided by 3 over 9, and if I divide the first numerator divided by the second numerator, 7 divided by 3, this divided by this, let's see what happens. 3 goes into 7 2 times. 2 times 3 is 6, so remainder 1 out of 3. Matchy, matchy. They're both the same. So one of the ways you can divide fractions is if they have a common denominator, just divide first numerator by second numerator. Let's do another one. 5 over 6 divided by 3 over 4. Now in this case, we don't have a common denominator. We need to find the common denominator of 6 and 4. The lowest one is better, but any one is fine. So the lowest common denominator, if we skip count, 6, 12, 4, 8, 12, the lowest common denominator is 12. So 6 times 2 is 12, 5 times 2 is 10. 4 times 3 is 12. 3 times 3 is 9. So what we have end up happening is 10 over 12 divided by 9 over 12. Well, let's take our fraction strip. Both of these fractions are still below 1 whole. So we want to divide this into 12 equal parts. Let's do half, then quarter, and then each quarter we could make into 3. And we know 4 times 3 is 12. So there's your 12 equal parts. Well, should be equal. I sort of did that not very well, didn't I? But let's pretend they're equal parts. Shade in 10 of them to show 10 twelfths. Okay, so there's 10 twelfths. That's the first fraction, right? Well, we want to know how many 9 twelfths are in 10 twelfths. So we want to know how much of this amount, 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many 9 twelfths are in 10 twelfths? Well, I count 1. So there's 1 of them. I count 1, and then there's also 1 left over. So how many 9 twelfths are in 10 twelfths? I'd say 1 whole. There's 1 left over out of what should have been a group of 9. 1 1/9. Now, if we're not sure about that, let's check with the common denominator method. So if you take your fractions that you made with common denominators, 10 over 12 divided by 9 over 12, and if you just divide first numerator by second numerator, you should get the same answer that you got from the diagram. 9 goes into 10 one time, remainder 1 out of 9. And you get matchy, matchy. Okay, so that's a beginning to the dividing of fractions. In the next video, we'll do a couple more of these, and we'll look at improper fractions and mixed numbers. So there'll be another video coming up next. That's all for now. Flexing Teacher Weber, out.